You are likely watching this right now on a tiny slab of glass that possesses more computing power than humanity could build a few decades ago. But all of these wonderful machines rely heavily on a handful of obscure, highly specific elements, metals with names like terbium, neodymium, and tantalum. Getting those elements out of the ground and into your pocket requires ripping them from the earth on a massive scale. Extracting the usable ore from the dirt involves drenching the rock in hazardous chemicals like cyanide and sulfuric acid. This process generates millions of gallons of toxic runoff that bleeds into local water supplies and suffocates nearby ecosystems. To keep building better technology without poisoning the landscapes we rely on to live, we have to look past the earth entirely to find these materials. Floating right over our heads are millions of tons of pristine iron, nickel, and platinum, locked inside of asteroids. There is enough raw material out there to supply our industries for millions of years. Yet, all that wealth remains trapped behind a punishing cost we call the gravity tax. Every single kilogram we send into low Earth orbit requires thousands of dollars in rocket fuel, relying on the sheer brute force of chemical explosions to escape the planet's gravitational pull. Securing a clean supply chain means solving a very specific physics problem. We have to bypass that astronomical fuel cost to make retrieving these space rocks ridiculously cheap. We know reaching these rocks is possible because we have already built and flown automated probes to intercept them and collect samples. To do it profitably, we replace standard rockets with electric spacecraft. These engines lack the raw thrust to launch a ship off the launch pad, but once they are up in the vacuum of space, they need almost zero fuel to travel vast distances. We can shrink the requirements even further by aiming our early missions specifically at near-Earth asteroids, space rocks whose natural orbits already bring them relatively close to our planet, cutting transit times down to just a few months. By pairing low-fuel electric propulsion with targets that are practically right next door, we strip away the massive fuel tanks and drastically lower the price of getting there. Once our electric ship arrives, the first task is to secure the asteroid. These rocks have been tumbling chaotically for billions of years, so we have to stop the spin by vaporizing small sections with a laser. This diagram shows the logic of orbital mechanics. Applying a small force at the exact right moment shifts the trajectory using incredibly little energy. We simply nudge the rock into a path that brushes past the moon, pulling the asteroid into a stable loop around Earth. Let the mechanics of the solar system do the heavy lifting. Manipulating natural gravity rather than burning synthetic fuel turns a physically impossible retrieval mission into a highly profitable reality. With the asteroid parked safely nearby, we launch our automated processing equipment directly to the rock. Processing ore in zero gravity is surprisingly clean. Instead of chemical baths, giant reflective arrays gather ambient sunlight and focus it into an intense beam of heat to boil away surface gases. Next, mechanical grinders crush the dried rock into gravel and dust. We then feed that material into centrifuges, spinning it rapidly so the heavy, dense, precious metals effortlessly separate from the lighter, useless rock. To get the refined treasure back to the surface, the orbital factory uses onboard 3D printers to manufacture cheap, heat-shielded capsules filled with structural gas bubbles. The pure metals are packed inside these highly buoyant pods and drop straight down into Earth's oceans, where naval ships simply tow them to port. By utilizing zero-gravity manufacturing and passive oceanic drop-offs, we completely eliminate the need to ever build or launch heavy return rockets. This graph shows the compound effect on orbital economics. The exorbitant price tag applies exclusively to the first mission. Once secured, spacecraft components and propellant can be manufactured directly in orbit using mined metals, with production capacity scaling rapidly. As raw materials rain down from space at a fraction of their historical cost, the terrestrial mining industry simply gets priced out of existence, allowing us to permanently shut down Earth's open-pit mines. The entire practice of digging toxic holes in our ecosystem to extract electronics components will eventually look like a bizarre, primitive habit. It will seem as absurd as keeping an unventilated campfire burning in your modern living room. We do not need to wait for a miracle material or a new branch of physics to achieve this. Transitioning our heavy industry off the planet requires only the technology we already possess and the collective will to initiate the first push.